sin comprometer el diseño elegante. Dubeau también es miembro activo del Comité de Factores Humanos de la Asociación para el Avance de la Instrumentación Médica. Ha vivido y trabajado en Canadá, España y Estados Unidos. Vamos a darle un fuerte aplauso a Serge Dubau.
Thank you very much. So I'm gonna, my presentation will be in English. Puedo hacerlo en español, pero mi español no es tan bueno y los términos técnicos son difíciles. Ya está, gracias. So what I want to talk to you a little bit is, I want to cover my background, where I'm coming from, a little bit. I also want to talk to you about L'Oreal, what we're doing over there, focusing on healthcare product development. I want to talk also about some case studies, some projects. I have 3 projects that I would like to share with you today. And this is the last part. What I've learned is when I was asked to present, I was asking myself, what would be of any value for this group? And it's a little bit different than the type of presentation that I'm doing usually. So it's not a presentation with a client or trying to sell a project or sell a company. It's very different, and I wanted to do something that I would have liked to learn or to hear when I was a student. So first thing, I was born and raised in Montreal, Canada, so a little bit on the other side, right up north. And I completed my studies in '94. Then I started to work at Hacia Design, which was at the time the largest industrial design firm in Canada. So as you can see, I started in '94, stopped in '98, started again in 2003, and then stopped again in 2007. So a little bit of back and forth over there. Type of products that I worked on, and now that you see buttons on a phone, it's quite bizarre. All sort of the range of projects were quite amazing, and this was a reference phone for Qualcomm. So most of the chips that you have inside your phones are coming from Qualcomm, and to show their technology, they were making phones, not for sales, but only to show off their technology. So they were doing full tooling for those phones, and they were making 100 only. Trains, this is the New York City subway. This is quite interesting. This was a anti-mine boots. So when people are removing the mines, they usually forget around 1 to 2% of those mines, and they step on it, and then they blow their leg up to their knee. So having those type of boots, when you're stepping on a mine, it's not your foot that flies away, but just the leg of that. That you probably recognize, the WD-40 can. And in terms of volume of production, for example, if the phones here were only 50 units, the WD-40 can, they passed the billion unit. So that is another level of shoes, because I guess you'd have to design a shoe at one point. This is also a very nice project. This is the flight simulator. CAE is the largest flight simulator manufacturer in the world, and we had the chance to do their design of their flight simulator, including the inside of it. So you have, so this is inside this flight simulator. So the size of this is gigantic. I mean, this is like a huge piece of equipment. Yeah, and that's where I learned to speak Spanish. So I, between my stints at Gatchen Design, I went and moved to Madrid to work at the Mobili. And then over there, I worked on projects that were a little bit different than what I used to work at Gatchen. This is the Sertelinas, all the urban furniture, papeleras, bancos, all the different signage system in Spain. So now it's all looks like that. Did proposal for front hand of Sertelinas trains. Also, something that I did over there that I was not thinking about doing ever was retail design. And the first time my boss came in and said, "We're going to do retail design," and I was like, "Oh, this is not fun." I don't know how to do that. And it turns out that it's super cool to do. It's really nice because at the end of the day, you see a store and it becomes a product. And it's a product to sell products. Right? It's kind of like funny to say that, but then you start to think in a completely different way how to make sure that every product inside the store people will buy it. So I really enjoyed it. That was a lot of fun. The other fun project was to do the design of the interior of the Airbus 3XX at the time that became the Airbus 380. So this is a mock-up. And with this mock-up, they sold a plane. So I worked on the seat and all what we call the dashboard, the ceiling, and all that. And we worked with a design studio in London to do that. But this was built in Toulouse, in France, and it was just beautiful mock-up, two level in the plane. And both levels in the first class were done. And then after that, I came back to Montreal, worked at Gatchen Design, and then after that moved to Wilbar. And Wilbar is a company that makes above-ground pools. And that was a client of Gatchen Design, and I decided to join them. And all the design engineering of pools were done in Montreal. And the nice thing about it was for me was a way to discover another side of developing a product. I compare working in a design studio when you're just a consultant is like being pregnant. So you're pregnant, you give birth, and then you walk away, and that's it. So the company is usually raising the kid, right? And so here, you were actually involved in every aspect of it. So we work on different concepts of what could be the future of above-ground pool. And here's that's a pool with a spa integrated into it. So you have two different zones. And the nice thing was actually to have the factory behind, and then you have people from the factory just walk to you very angry. It's not working, it's not working. Then you look at the revisions of the drawings, and he was using the wrong revision. So it was always interesting, and or receiving calls from customer service when people at customer service were kind of confused about the question, they would transfer the call directly to you. So you're working at your desk, and you're receiving a call, and you just pick it up. And it's like a guy installing a tool somewhere, super angry because it's not working. So that was another aspect of my work that I experienced at that place. And this is where I work now in Minneapolis. So very close to Canada, but still. And we have an office in Shanghai as well. And that's what I wanted to show you a little bit what we're doing with it. So, except for the pool company, all the places that I work, we were still doing medical devices. Sometimes, we did not really know what we were doing, but we were still doing medical devices. And at L'Oreal, that's what we do, I would say 95% of the time. So L'Oreal started in 41 years ago, so it's 1 year older than this program. And Bob L'Oreal started the company, and we're focusing, as I mentioned, on healthcare products. So we do a lot of ethnographic research. We do a lot of industrial design, of course. Fun stuff going on there. And then we have mechanical engineers, we have human factors engineers, and a full prototype shop. So we are about 40 people in Minneapolis and 10 people in Shanghai. So it's around 50 people, the entire group. So that's a lot of projects that we're working throughout 1 year. I would say it's around 40 to 50 projects. And we work for the largest medical device company in the world. So that's very interesting because we have very good budgets. So we're able to do a really good job and invest in quality product development. So that's really nice. It's a fun video to watch, I like it. So that is some of the space that we have, and I'll talk a little bit about what we do with that space. So those are the different departments, if you want, that we have inside of L'Oreal. We have research and strategy, industrial design, engineering, and prototyping. We have user experience. Imagine more like interaction design, so everything that is like a screen when you're touching it and everything that is happening. And we have human factors engineering. So sometimes there's a little bit of confusion about what is human factors engineering. It's obviously the ergonomics, anthropometrics, measurements, and all that. But when you are doing medical devices, potentially what you will be designing may kill people. So that will be laughing, but that could be the ultimate of what could happen. But you can really hurt people or slow down a surgery, and that will create some problems for the patients. So FDA, which is the American organization that control the release of devices, right? If you are not FDA approved, you cannot sell your product. You cannot commercialize it. So, and FDA requires that you prove that your device is safe for use. So that is a lot of testing with people to make sure that it's safe. And people, I'm not saying us, unfortunately, we're talking about surgeons, nurses, all sort of technicians, and needs to be technicians that are specialized in what your product is for. So we're testing around 1,000 people every year using prototypes and devices. So, and I'll focus today on those two areas that I think are the most connected to you guys. And you'll see that in the case studies. I'm going to also talk about the other areas. So what is ethnographic research? So by definition, it's to observe how people are using product devices. The difference between designing this microphone, this remote control, this computer, is that we are all familiar with this environment, this product. We can actually start designing right away because we know what is a microphone. But when you're designing products for a surgeon, I don't know how he's using the device and what the device is for. So the only way to know and to learn that is to actually go see surgeries. So we have like a joke at the office that every day there's someone from L'Oreal that is at the hospital, right? But for good reasons. And it's always to observe in a clinical setting how devices and products are being used. So so far we probably observed more than 1,000 physicians doing their job by watching how they do that and try to extract some user needs and make sure that whatever we're going to communicate to the designers are correct, that everything is correct. We've been in more than 500 hospitals. We studied or taught, met patients or caregivers, more than 1,000 people in more than 20 countries in the world. So here's what some of the outcomes of doing research means. One is meeting a lot of people. So sometimes we go in their home, like here. So that is going from recruitment to those participants. And every time you have to enter their home, explaining the project and go through some of the questions that you may have. We're creating a lot of visual infographics also as an outcome of those research. We are, as I mentioned, very often in the OR, filming, keeping. Most of our clients wants to document in a form of a video everything that we're doing. So we have to get permission to film patients being operated. So that's quite interesting. We are always presented as researcher, clinical researcher, which is not true, but it helped to have their signature to authorize us to be in the room as they're during the surgery. So we do a lot of also workflows to understand all the steps that will be used in the surgery on how people are using devices. And it's a way for us to learn the surgery basically, or to learn how someone will be using those devices. So here, a lot of meeting with nurses. And then what we do very often is we'll do what we call a co-creation. And what is a co-creation? Basically is we go in the field, we do a lot of research, it could be 6-8 weeks, and then we come back and we have all the material, all the videos, and we do a summary of that. And then we invite the client in. So we're going to invite people from marketing, finance, engineering, sales, clinical support. It could be every area of the company, and all the stakeholders that are involved in that product. And when they come back, we just go through the synthesis of what we saw in the field. And what happened is after a day or two all together, and we're planning this throughout 2 days, for example, and at the end, what we have is a consensus, if you want, on what we should be doing. So if your client is a company that has 100 people, you can get to a consensus very quickly. Here we're dealing with companies like Johnson & Johnson or Medtronic. There are 60,000. So you can have 200 people on a project, and it might be in 5 different locations on the planet. So how do you get alignment on what decision? For us, using that co-creation day is something that works pretty well. Other thing here is what we call a discovery kit. And discovery kit basically is a box with video cameras, activities that is given to participants. So the problem of doing ethnographic research in people's home is that you cannot be there for 1 full week. I mean, I'm not going to live with people for 1 week. So what do you do to be able to gather all the information that you need throughout, let's say, a full cycle of someone using your devices? So we're giving those boxes, and we're designing for every single project activities that they have to fill every day, and then they have to comment on, and then they have to film. So sometimes products are being used and it's in relation to their environment. So we want to see those things. We don't want to just like have them to comment on it, but we want them to film it. So that's why we're supplying them with this discovery kit. Then they send it back to us and we do the synthesis of it. And yes, they receive a lot of money to participate in that. Good for them. The other thing we do is to place 360 video cameras in a surgical suite like this, and after that with a VR viewer, you're able to actually look at exactly what you want to have information with. So that's what we're doing now, is almost filming everything in 360, and then everybody on the client side can decide what they need to look at. So that brings us to product design, which is basically what you guys are doing, and it's how do you bring that back into the real world, and how do you really, now that you saw all those things in the field, how do you translate that into an actual product? So again, the range of projects or products is quite large. It could be devices that you wear, but sometimes we have to deal with products or type of equipment that is unknown to a surgeon. So since our clients are developing the core technology of what will be packaged, that technology is unknown to the users. So we have to sketch storyboards on how a surgeon would use the device that we intend to design. So it's really bizarre to explain to a top surgeon, a neurosurgeon, for example, how he's going to be using this new technique, because the guy in front of you is clearly way more intelligent than you, and you're there explaining how he's going to do the surgery. So sometimes it's very, very funny. other examples here. Obviously, this is a part that is extremely important, and I think that is sketching is still, I would say, a good third or 40% of everything we do. And unfortunately, sometimes it's easier to learn how to use a software because you feel very secure using the software. It's easy, right? And sketching involves a lot of work because you have to practice a lot. But it's still one of the skills that is the most valued. And forgot about that, but something interesting is we're receiving, every time we put a post on a job, we're receiving around 200 to 250 applications. And you should see the speed at which we are reviewing them. I mean, no joke, we're opening it and it's done. That's it, out. Because what we see is not what we want to see. And most of the time, it's all computer skills. But computer skills is only one skill, and to generate those sketches very fast, very quick, that's where ideas are coming out, and it's fast. If you have to model everything, it's going to take you a lot more time, and you will generate a lot less ideas. So, sketch is number one skill that you have to have, at least in school, when you're coming out, according to, again, what do we know, right? The other thing that we're exploring is the augmented reality for industrial design and how to present our concepts. So that's the next phase for us. How can we design products and provide HoloLens to clients and ask them to literally look at the concept that we came up with. So that's pretty cool. All right. So now that we've talked a little bit about, you have an idea what we're doing in terms of ethnographic research and industrial design, I'm going to go through 3 different case studies. The more you go, the more dangerous it is. So the first one is Grace and Stadler. They're the leaders in audio screening. So the type of things like that when you have a child or even later in life that you have to go and start to have your hearing being tested. So what happened with this company is they have an amazing technology. It's top notch, but their devices look like 1950. I mean, it's bad. And they got a new CEO and coming from Denmark, and then he really started pushing industrial design. So they wanted to have a design that was in relation with the quality of their electronic. So we started with a series of concepts, and this is just for one of them. We've done 5 or 6 different devices so far for them. And this was a quick rendering, we call it quick and dirty, so very fast. Looking at the placement of all the electronics and all the components, as well as the rapid foam model. So those foam models were CNC from a 3D CAD file. But this is sufficient for a client to give you the go-ahead to continue. So this type of mock-up is great to evaluate form and volume, and you can actually start to use it. And this is the final devices that was put on the market. And this is another one. And another one. So what was interesting for them, with them, is we were able to develop what we call a design language. So a lot of our clients are looking for that when they have multiple products. They may have 10, 20, 50 products, and how do they change and modify and make sure that without seeing the name on the device, how can they recognize it? So here we have like all those curves and shapes, and it's always like a cradle, two pieces that it's very hard to talk with my hands and the mind and the remote, but so two parts really connecting together. So this was a design language that we developed for them. Every device has a different intent, and it's for different purposes, yet when you go on their website, it looks like only one person designed the entire line. And still today they have a few that needs to be designed, and it's a clash on the website, because you have those devices and then you have stuff that looks like 1950s. The next one I want to talk to you is about, it's from Medtronic, it's called Visualize, their product. And what it is when you have a tumor in your brain, it's usually the surgery involves removing part of your skull and going in your brain and remove the tumor. The reality behind that is after that surgery, you will be alive, but you might not be a normal functioning individual. So you may have like some serious cognitive issues, not able to walk, talk, or even think. So this system, and I have a little video here to see that, and that's their corporate video. So you literally drill a hole in someone's skull, 3 millimeter in diameter, just the depth of the skull, you know. There's a way to block it so you're not like, oh. And here you do a scan on the patient and install a fixture to align the drill, and that you know the angle and the direction based on 3D scan of your brain prior to the surgery. So you're not just like, there's an improvisation here. And then after that, they install an anchor that they literally screw on your skull. And then after that, you can remove all the guidance, the frame that you see over there. And then you insert the probe. The probe goes literally through your brain and goes directly to the tumor, right? And then under a MRI system, so a 3D system, they can visualize where the probe is, and then they start to heat up the laser. So they just warm up inside of the tumor, and that kills the tumor. So that's very simple, right, in principle. So they warm it up here, and then you're going to pull back a little bit, do it again, and pull back again. So you could have, depending on the tumor, 2 or 3 different probes that will go to your brain, depending on the shape of the tumor, right? It's never like just a sphere. It's a fairly complex shape. And then after that, they can see that they burn everything. And then they just remove the probe. And that's it. They put literally a Band-Aid on top of the hole, which, wow, it's like crazy. But so I saw surgery, the one